in this demo section, we're going to show a Terraform demo for orchestration. The scenario here, we're going to go back into what we call our bank N personas. So I'll talk through what that means and how that works. But we're going to be showing an enterprise that is basically trying to terraform bare metal, doing things like setting a target OS, running Ansible as part of that process, and then talking through how they would do security audits of infrastructure that was provisioned through Terraform. We're focusing in on making it available, reliable, and fast. So an easily recreatable environment that has a high automation success rate and then ultimately drives a lower average system age for all the people consuming infrastructure, because they can create and destroy much more easily than they had been able to before. The architecture that we're going to show you here relies on a digital rebar feature called pooling, which is probably exactly what you expect it to be. We have defined a pool of machines that are available for being checked in and checked out. Terraform for us uses that mechanism. So it's a give me a machine. It's a very cloud-like API. You don't know what machine you're going to get. You say, I need a machine that matches the specification, and then you're able to check it out. So you check out a machine, it runs an infrastructure pipeline to set the machine up to your specifications. You use the machine, right? In the background, the digital rebar can see and control that machine. So we could use that ad hoc task capability to do a security audit. And then when you're done, you do a Terraform destroy, and it checks the machines back into the system, and they get cleaned up and reprovisioned. And at that point, you now have pools of infrastructure that are back and ready to go. So imagine multiple people using infrastructure Terraform plans against a shared resource pool. It's exactly what you'd expect from a cloud. For this demo, we're going to be going into our bank-end personas. So I'm going to be the role of a developer of platform engineering, right? Somebody who's been charged with helping a streamlined team consume infrastructure using Terraform. And Shane is going to be our senior infrastructure architect who understands and drives digital rebar and runs infrastructure on a regular basis. With that, Shane, you ready to take the con?
Absolutely.
All right. So in my persona as a platform engineer, I'm visiting Shane, asking for help. I like to use Terraform. I want to be able to check systems out. I already have a CI/CD system that's going to be set up to do this, and my team is used to it. So, I really don't want them to have to log into Digital Rebar. Frankly, that's a little confusing. I just want to use Terraform. Can you hook me up?
Absolutely, absolutely. So through the platform, we can allow you to request resources from given pools that allow you to check out those resources and then be able to drive them through a pipeline to a declarative end state. So you can be in control of what they end up with. And then once you have those fully built resources, you can use them for however long you need. You do your standard Terraform destroy, and that returns it back to the pool to be reused by other team members. And then also through that destroy process, we'll go through a decommissioning capability to clean the machine up, reset it. Potentially on bare metal infrastructure, we can do BIOS firmware, hardware RAID resets as well, and ensure that the machine at the platform level is returned to a known good working state before we drive it forward again.
As a developer, I only heard I get a machine and then I give it back.
Oh yes, you developer types.
Okay.
So let's make this easy. Yes.
Okay, just making sure. I'm sorry to interrupt. So start again with the let's make this easy.
So, and I want to make sure here, because I just use Terraform, and I don't need to use like the ops backend version of Terraform or anything like that?
Correct. The only thing you'll need with Terraform is the DRP provider, which allows you to interact with the API of the platform. I get to control the resources, you get to use them.
That sounds like a good contract to me.
So let's talk about what you need to do first. First and foremost, as with any Terraform, you need to be able to initialize the Terraform, pull in the appropriate provider. And so it's pretty straightforward. You should be familiar with that. You need to be able to provide some configuration for that provider. Now, in this case, we're going to provide the configuration about which DRP endpoint that you interact with through standard environment variables. So we don't really need to provide a whole lot of information in the provider stanza here, but you can provide the endpoint information here. You can also provide the username and password that's been provided to you for the API access and your API token key. But where the real working body of this comes in is actually consuming the resource. And so this is very straightforward and simple in terms of allocating a resource. And so the DRP machine resource allows you to request machines from the appropriate pool. And in this case, we've gone to a little bit of extra work and we've created Terraform variables for those to abstract that out. So from a Terraform perspective, you can run multiple plans with different input variables and be able to maintain control over multiple clusters of infrastructure. So it's pretty straightforward. What we will be doing as we operate these is just specifying primarily the pool that you're going to use, that you're going to pull resources from, and ultimately where you're going to drive that machine to by a simple profile configuration. So those are the real primary constructs that describe the changes or the configuration values you need. Of course, you need to know how many machines, so you can pass in the number of machines you'd like to be able to consume. So pretty straightforward, basic Terraform constructs.
So I'm learning Terraform here. In the other Terraform I've always done, I've just put stuff in quotes here. Like the pool I need, I put like 6 or 7, whatever I need. Like this is cool. So you're actually controlling these things with variables?
Correct. So the variables input allows you to define variables that can be assigned into those resources, into the HCL resources when at runtime. So at runtime, you can affect change without having to rewrite the configuration stanzas.
I'll have to try that.
You can make multiple runs.
People do it this way, by the way, and I include myself in that.
And so those are the primary constructs. So yeah, we delved into the vars a little bit. And then ultimately, the primary thing that you also need to know how to construct is what you're going to do with that machine and driving that pipeline interaction on the machine. So within the DRP platform, it's pretty straightforward. We call a pipeline with a special profile name, universal-application, that describes the pipeline and then describes the chaining process that it's going to do to get to its end state. So for example, you want to get a Photon OS Linux installed on a virtual machine. So you want a cluster of virtual machines, could be a cluster of bare metal machines, because bare metal takes forever in 3 days. To be able to boot, post, and go through all of those cycles, we're going to do a minimal presentation on the virtual machines, because those constructs are a lot faster to drive through and see. Photon OS I happen to like. It's VMware's Linux distro that's super fast to deploy. I don't actually really use it much outside of that, but it's very fast to deploy and easy to show you how this process works. And so from the profile perspective, we have things on the RackN side that are called profiles. And the profile is essentially the same thing. We like to carry a fair bit of additional meta information about the profile, so you can pass on to other people that may use this, things like documentation on how to use this. That's a very nice thing to be able to provide. But at the end of the day, the real working body of what we're doing is we're specifying a pipeline for Photon for Linux. And then you presumably want to do some customization when you're done with deploying Photon. For example, you want to run an Ansible playbook that may install an application workload or configure that system for your use case.
Wait. So I don't have to then Terraform and then run Ansible?
Nope.
I can just add my Ansible here and it's
just add your Ansible here.
All right, that's handy. All right,
handy.
That'll save me another tool.
Exactly. And so that's where we're specifying here that we're going to inject some additional custom tasks that are run on your behalf, just for you in this special operation, in this run. And then we specify which Ansible playbook that we want Ansible to actually run. Now, Photon Linux doesn't actually have Ansible installed in the OS by default in our base image that we distribute. And so you will also need to install Ansible to be able to
But I can just use this and change out to my Terraform? I can just give you some some Ansible and you'll add it and I can just specify it here and it's done?
Correct.
It's handy.
Yep.
Okay.
Very handy. So now we get back to the nitty-gritty of how Terraform operates and runs, and we need to, we're going to jump over to the RackN portal that I use to view infrastructure, so you can see the changes happening to the platform.
Yeah, that's a lot of buttons.
Yeah, well, you don't have to see this.
Oh, good.
All you're going to see is Terraform whatever you want to do. And this is what I get to see on the back end, so I understand what's happening with the resources and how the resources are being consumed. And if there are any issues with the build process or automation, I can ensure those get corrected, or I can cordon those machines off and take them out of the pool so you have only good resources available to you.
Cool.
So we're going to look at a little bit of both views. And in this case, we're going to take a look at the clusters. And so I have prepared a cluster called the Raven cluster because we have these fancy icons that have animals on them. So I picked Raven for this cluster. And so the Raven cluster is interacting with a KVM Proxmox virtualized hypervisor cluster, and we can request machine resources from it. And I've pre-allocated 5 virtual machines out of that. So we've talked a little bit about this in previous conversations when you want to create new infrastructure resources in, say, Amazon, GCE, Linode, through some of the other cloud wrapper capabilities that you've worked with in the past. You can also do this on bare metal, just using the interactions with the Proxmox hypervisor. So you get virtual machines there. Similarly, a pool could be contained of physical machines. So if you actually need real grunt to get some work done, you want all of the bare metal yourself, or your application workload requires it, we can allocate those physical machines out of a pool with physical resources into.
Yeah, but I don't have to set those machines up. That sounds like a pain.
Very much so, it is. Trust me, my friend. Trust me,
Okay,
it is.
so I don't have to set them up?
No, you don't,
Okay.
because part of the pipeline declarative process is we can drive that machine from the beginning all the way to the end, including things like special firmware versions that your application might need, or drivers for GPUs or data processing units, or BIOS configuration values to increase the performance capabilities. So there's a lot we can do there with that pipeline. So from this perspective, we've done our initial Terraform init, which pulls in our provider, and we are going to simply do a Terraform apply, and we're going to do a cheat and just bring it up in the command line. So we're going to apply, and hopefully that's visible. We're specifying the profile. So again, we do that vars and that profile. So in this case, we're going to deploy Photon Linux on here. And so this profile is that one I just showed you that describes.
So when I call, I can literally in the command line pick which OS I want it to do.
Yeah, pick the pipeline you want to drive the resources towards. And in this case,
I don't have to have like 6 directories with whole different Terraforms. I can just switch it in the variables here. That's pretty cool.
Correct.
Okay.
And then I'm also showing an additional construct here where you can specify a file that contains the variables. And so that file also contains additional configuration variables. So you have a couple of options on how to drive infrastructure. That file describes 2 machines that we're going to allocate. So by kicking this off, and if we take the ampersand out from the front of that, so we actually execute it, we're going to see that Terraform starts its normal thing. And what's happening in the background is it's already allocated 2 machines, Raven 1 and 2, from that cluster, and is now starting to drive it to its declarative end state, to its final destination of Photon OS Linux. And just to show you that, we got to determine, sorry, let me go back to which machines that was, Raven 1 and 2, I said. So if we come back to the physical consoles in the Proxmox platform, you can see these machines as they drive through the automation. And they've gone through an inventory stage, a baseline configuration stage in our ephemeral OS that manages it. And now we're actually starting the Photon Linux installer. So this will all be done for you through that simple profile that you apply to the Terraform process. And in this case, it takes about 3.5 minutes for Photon to finish installing and reboot back into it.
So when I'm doing this on my desktop, you're going to see every time I check something out, you can watch that process?
Big Brother's always watching, my friend.
Excellent. All right. Well, so if I need help, I can call you up. And
Very much so. And then I will understand the state of the system and where it's at, or where something may have gotten hung up. And then I can help you through that. Or maybe you've applied the wrong profile, wrong pipeline destination, and we can get that fixed and return the machines back to the pool, and then get them reallocated to you with the correct process necessary.
Super handy.
And so that's essentially what's going to happen. And then on the Terraform destroy pass, we'll drive it through. And this is something I've defined because I want all of this infrastructure to go back to a clean state. The machines will be returned and reset to a clean state. The drives will be wiped clean. everything will be reset to a known good BIOS firmware RAID configuration for bare metal infrastructure, and then they're available for somebody else to use within just 30 seconds to 45 seconds after you've done your destroy. They're now available for
If I put secret data on those machines, what's going to happen?
wiped clean. We run a shred process on those drives, so we can wipe those drives and ensure that they're wiped clean. You can choose additional data destruction processes at specific governmental compliance requirement levels through additional plugins that we can add to the platform. But the standard wipe process is generally going to clean everything off the system.
Cool. Looks like it's doing my Ansible thing too.
And indeed, now it's kicked off and running Ansible apply now. So that Ansible job is going through the process of, and there it is, it's done already. So it installed Ansible, and then it ran that Ansible playbook for you. And so that Ansible playbook has now been run on the system, and we've returned to our complete state where both those machines are now completely ready and built and done for you to use. If you wanted to be able to see that, I can see that process in the platform. I can come back and see the job history and be able to review all of the things that occurred on that platform, so we can troubleshoot or debug where something may have failed if something had failed. And also ensure compliance and audit controls for
Okay,
cloud.
so this is where if you could do a security audit of that machine after I've provisioned it and just do a nightly check or a weekly check.
Correct.
I apologize if you already said this, but does it have to be Terraform and Ansible?
No.
Or like it could
Yeah.
be Pulumi, it could be
It
Cloud
didn't-
Formation.
absolutely.
it could be-
Salt Cloud, Salt Stack,
Yeah.
whatever. That's actually, you're touching on one of the things that I think is the unsung hero with our platform is what's today's tool to do the right job is not the right job for tomorrow. And our platform is essentially gives you the ability to maintain state over a set of operations, manipulate that state in different tools to affect the input and the output outcomes of each of those tools. And so we can bring Terraform together with Ansible in this case. We can bring Terraform with your own Python scripts, whatever it happens to be that you need to do from a customization perspective. We can compose those into the process.
The same API could be used for a Terraform machine controller to check a machine in and check a machine out. It's an API. With that.
The way I'm thinking of it, and correct me if I'm wrong here, but the way I'm thinking about it is something like Microsoft Azure. They have their resource manager that runs in the background and handles all the provisioning and doing of things.
Yep.
That's not what they present directly to you. What they present is an abstraction in the form of APIs and a portal. But you can use Terraform, you can use a scripting tool, you can use whatever the heck you want, as long as it ends up talking to that resource manager API.
Yeah.
So would it be accurate to say that sort of RackN is the resource manager, but for like private cloud or bare metal?
Or for any infrastructure. But yeah, that's exactly, we are cloudifying bare metal without a doubt from that perspective. But you could put this in front of anything. If you had a pool of VMs or a cloud infrastructure, you could use the pool as a buffer zone to collect machines and then create an intermediate so that people aren't getting the machines themselves, but pulling them out of a pool or indirectly with a resource broker.
So typically someone who's in a consumer role, like you're playing right now, wouldn't log into the RackN portal.
Correct.
They would access this through something else like Terraform or maybe like a developer portal that you set up to talk to it in.
And we're
That'll
and
demo
that's a good segue for. Do you want to show the Terraform destroy just to let us go, and then I'll show you Backstage on the other side.
And so Terraform destroy, standard process. We go through the destroy, come back to the machines, and we see that these machines are now going through decommission process, which includes the disk wipe, and then returning them back to a clean state into the pool. We'll also,
if an error state occurs where, say, during deprovision, it times out on something just because of a Terraform oddity or a blip, and all of a sudden we've got 2 out of those 5 machines are in an indeterminate state now.
Yep.
How is that state held, and what happens to bring it back to a known healthy or empty state?
great question. So there's 2 answers to that. As a user, that's your problem. Terraform state. Now, we assume that you're going to use some sort of Terraform tool that helps you with that state control process. From a platform perspective, where we integrate Terraform, and we have integrated Terraform in some pieces as an API abstraction to public cloud resources, we maintain that state through the HTTP providers. And so we've automatically built and used Terraform in a capacity very similar to some of the enterprise Terraform management tools do, that allow you to record state and allow you to discontiguously operate on that state, either from different individuals or from within the platform at different runtimes, and to inspect that state and maintain the control over that state.
The other thing you'll see with this is pools have accommodations for error during pool state change operations, and it'll go into a pool error state, and you'll be able to remediate. If you can remediate, you can pick it up and it'll continue, and then it'll be back available, or it'll just show up as errored in pool transition.
Right, and that's not a you problem. That's a it just could not have worked problem. That at least now you're aware as a platform that you can attend to it through the platform. But I was like, when I asked about what happens when it goes wrong, it's not that it's now a RackN issue. It's that nothing could have saved it. It's just that RackN has.
And it's worth noting with this. RackN makes infrastructure more reliable, not by fundamentally creating magical infrastructure.
Right.
It creates more reliable infrastructure by actually having better transparency, by having shared code, by stopping on errors before they become much more severe errors. So we're actually resolving issues from a reliability perspective by providing APIs that improve your ability to control and manage and fix, rather than, oops, I don't know what happened. I can't find that gear anymore. It's in a weird state. We make that's the secret to reliability. It's not like making hard drives better, right? It's accepting that they aren't.
I don't want to be like the pedantic word person,
but
I'm gonna be. Reliable versus resilient. It's an interesting choice. Like resilient has other implications. I think of what you do is creating resilient infrastructure, that it will. There is resiliency in the fact that you yourself have resilient platform, and then you're creating opportunity for resiliency. But you talked about reliability as the descriptor.
Yeah, reliability is we're very focused on the consumer of the API. They might not care about your resilience, but they really do care that when they make a Terraform call, that it executes work. Or even, and this is a funny thing about reliability, if it's going to fail, the Terraform will tell you it failed. So part of reliability isn't just that it always worked. It's actually that when it breaks in predictable ways or with good error messages. So they're both important from this perspective.
Cool, thanks.
Yeah, quick question.
Okay.
How do you handle secret during every correction step? So probably I missed something. How to keep secret?
So within the platform or within this construct?
Yeah, within the platform.
So within the platform, there's a couple of answers we have for you. We use what we call parameters, which are essentially variables. We use type-defined parameters. We are very structured from that perspective. And one of the type-defined parameters you can define is a secure param, which has an automatic encryption capability in it. And then you can define based on roles who can or can't read that or write those values. So it's essentially like a lightweight vault. In addition to that, we have a Vault plugin that allows you to integrate with other external third-party vaults, not to confuse Vault term with HashiCorp Vault. HashiCorp Vault is a plugin within the Vault service we expose as well.
And you are able to integrate also the HashiCorp Vault in your
Correct.
Your process.
So you can do secrets from external Vault services, or you can do secrets that are embedded within your infrastructure as code at rest on disk, or only embedded in process and in flight when being used. You have the choices on how those are used.
Gotcha.
And I'm going to roll through in the Backstage so we have enough time to show you that and give you some questions.
Yeah, sure. And just on the secret thing, can you operate just as a secret management for other tools? Like, why would I?
Yes, you can.
Like, why wouldn't I?
You could.
Why run a second Vault installation if I can just trust
It's not our
it?
focus, but yes.
Yeah, that's cool.
It's an API. We can have parameters are secured. You can request through the API after you authenticate and you have roles. Absolutely, we could do that.
Cool.
So for our second demo, we want to show using Digital Rebar as the back end for a control plane. And in this case, we're going to be using Backstage, doing something pretty straightforward, setting up predefined clusters, allowing operators the developers to grow and shrink them, running Ansible as part of that work, and then doing garbage collection to make sure that if people are leaving machines around, that we can pull them back, and also that they know we did that. And to do that, to make it available, reliable, and fast, we're really working on making it very easy to reset, minimizing our change failure rate so that we really can have a system where people are confident that they're going to get the infrastructure. And then very critically for the operators, having reduced custom automation so that people are getting infrastructure without them having to go write their own Terraform or write their own Ansible to make that happen. The architecture for this, if you're familiar with Backstage, Backstage has a front end and a back end. I'm not going to delve a whole bunch into this, but it's worth noting as I navigate around. Into Digital Rebar, that API that will consume our clusters API. So instead of asking for machines, it's going to ask for a cluster. Cluster will automatically provide machines in this case. We'll go through that use case. I'll be able to expand and contract to get those machines back and then ask for new clusters. One of the things that's really nice here is that I'm asking for a cluster by name. It's getting created by a name. I don't worry about collisions or anything like that. I can actually build my infrastructure. And then when I'm done, I can delete that and have it just disappear off the scene.